Greetings everybody and welcome back to another exam video. So today we'll take a look at the 2023 Specialist Maths Exam 2, which finished not too long ago. And yeah, just got a copy of this exam from my Discord server, which is quite nice. And yeah, we're going to be doing the multiple choice section today. Probably not extended response today as well though, because I have an exam tomorrow and I kind of want to study for that. So we'll see how much of multiple choice I can get through. And yeah, I'll do extended response probably tomorrow when I have time. Yeah, so I'm also a bit rusty with Splash. I don't know how I feel about doing these exams anymore because I don't know how much I remember or how much I don't remember. And yeah, there's stuff that has changed because of the study design and so on. So we'll get through this. We'll see how much we can do. But yeah, let's jump straight into the first question. So we have these proof kind of things. So football team plays badly. They're not training enough. Which one of the following statements is the contrapositive? So, what do we have here? We have plays badly. This implies that, why did I put badly with an S? This implies that they are not training enough. So, not enough. So, how do you get the contrapositive? You reverse the implication direction and you negate both of these propositions over here. So, yeah, not enough. Negation of that is they do train enough. And plays badly, negation of that is they, don't play badly, I guess. So, not badly. So, we're just going to match the statements. So, if they're not training enough, looks like it's C. Or could be E as well, because they're training enough. But option C, this is the correct negation over here, because we want this to imply that they're not playing badly. Does not play badly, whereas that's not the correct negation. So it looks like it's option C. Question 2, we have rational function has asymptotes, that's the oblique one, 2x plus 1, and x plus 1, that's the vertical one. So my thoughts, let's see, if we do long division on this, we should get this guy as the quotient, and plus some kind of funny remainder. And we also want x equals 1 to be a solution to this quadratic. I don't know. Let's just brute force it on the cas. So I'll go expand, and I'll do x cubed divided by a times x squared plus b times x plus c, and we can just kind of match terms, I guess. So here's the principal part, and then here's the rational part over here. Not the rational part, the polynomial part. So because this has to be equal to 2x plus 1, we have a equals 1/2. Okay, so a equals 1/2, and we also want b over, or negative b over a squared to be equal to 1, right? Yeah, 1. So what I'm going to do, because I'm lazy, I'm going to grab this guy over here, and I'm going to solve that equal to, that's the constant, so that's going to be 1 with respect to b, such that a equals 1/2. B equals -1/4. And to get c, well, we want x equals 1 to be a solution to this quadratic, so I'll just solve a times x squared plus b times x plus c equals 0, where x equals 1, and we have this guy, and a equals 1/2. Solve for c. C is equal -1/4. Hopefully that's an answer. It's option B. I don't know if that's the most efficient way to do it though. There's probably a faster way to do it. I don't know. Question 3. We have interval, the graph of a plus secant. What does secant look like? I think that's the one which has the y-intercept at 0, 1. Has two x-intercepts. When? So secants, let me try to remember what secants look like. I think it's like that. And then the asymptotes would be at pi on 2, I'm assuming. That seems about right. So we have pi on 2, negative pi on 2. But this is from negative pi to pi. So we want these branches here as well. So that would be pi, negative pi, and then negative pi over here. A is a real number, so we're doing some kind of vertical translation. We want this to have two x-intercepts when. So we can, let's see, we can push this guy up vertically by 1 unit. So if it's 1 unit or more, then we get to these two endpoints over here being x-intercepts. So we could have a greater than or equal to 1, or if we bring this point down by 1 unit, but it has to be more than 1 unit, because this is a turning point over here, right? So, yeah, I guess or a is less than -1, that should be right. So, option E seems to be about right. I think I'm happy with that. A is greater, A is less than -1. Yeah, it should be right. Wouldn't be C though. Wouldn't be C, and wouldn't be the other ones. So I think I'll go with option E. Question 4. Z is this guy. A is a non-zero real constant. Then for A over 1 plus Z conjugate is equal to. Okay, so I'll define Z on the cuz. So Z equals, we have negative 2A plus 1, and then plus the imaginary thing, which is 2A times I. Let's make sure I got that right. So 2A plus 1 with the negative, and then 2AI. Okay, then we want to figure out what on earth 4A over 1 plus Z conjugates, so conjugates of Z, is -1 plus I, and we'll take the, yeah, we're just going to match it up. So it's going to be some root 2 something. -1 plus I, so -1 and then plus I. So the angle is going to be 3.4, so it looks like it's going to be option B. Yeah, I'm happy with that. Okay, question 5. Let Z be a complex number. Real part of Z is greater than 0. Imaginary part of Z is greater than 0. Given that conjugates the size of this thing, okay, and arg cubed is -pi, then Z squared is equivalent to... What on earth is this question? So let's try to understand Z bar, Z conjugate modulus. So this thing over here is the same as just the modulus of Z, right? Because if you have a complex number over here, if this is your Z, if you take the conjugate, you're just reflecting it, but you're not going to be changing the length, right? Lengths are invariant under reflections. So let's see, that means we know, yeah, this is equal to 4. Arg of Z cubed is -pi. We also know that real part of Z is greater than 0, imaginary part of Z is greater than 0. So it's going to be over here. So we have a positive argument. Okay, and when the argument of Z cubed is -pi, so we're going to be landing down here. This is the cube. So that suggests, let's see. What's so this is 3.2 here. That suggests that Z must lie on this red line here. Or maybe not. Because arg of Z cubed is -pi. -pi, what am I? That's not -pi. This is -pi. I'm so dumb. Why did I think -pi was down here? That was stupid. So that just suggests that, yeah, the angle is going to be pi on 3, something like that. So Z is going to lie on this ray here. And we want to figure out Z squared. So Z squared would lie on this blue ray, light blue ray. Modulus Z is 4. Okay. So we know modulus of Z, yeah, it's going to be right over here with the modulus of 4. So when we square it, it's going to become a modulus of 16. So 4 turns into 16 is equivalent to, won't be that. -2Z, no, won't be that because we want to, yeah, increase the factor by 4. It's probably that or that. It's either D or E. So is it D? Probably not, because when you take the conjugate, it's going to reflect it down over here, and you square it, so it's going to, yeah, end up over here, which is not what we want. How about -4Z conjugate? Seems about right though, because Z conjugate would reflect it down over here, and you do -4 of that, which flips it back over here and multiplies the length by 4, which gets you to a modulus of 16. So it looks like it's E. That was a bit confusing. Question 6. Consider the following pseudocode. I think this Euler's method or something. Probably. How many iterations will the pseudocode print 2.709. Let's see. So this is the starting step size, or n's greater than 0. Okay. I think I can just use the Euler's method program I have. Let's see if that works. So we have special calculus, Euler's method. There it is. And the function is e to the xy. X starting value 0, y starting value 0, x ending value. Well, we're only doing 5 iterations over here at maximum, and the step size is 0.5. So let's go for 2.5. Step size is 0.5, and we're printing the y value over here. How many iterations? So 2.7. It's going to be after. So this is the first iteration here. So after the first iteration of the while loop, we're going to go here. This is second iteration, third iteration. 709. Yeah, third iteration. Okay. Question 7. Slope fields. I forgot how to do slope fields. The direction field for a differential equation is shown above. On a certain solution curve of this differential equation, y equals 2, when x equals -1. So x equals -1, y equals 2 would be probably over here. Okay. The value of y on the same solution curve when x equals 1.5, so 1.5 is over here, is closest to, so we have to kind of follow the curve. Let's see if I can do this nicely. So it's probably something like this, so it's probably going to be 1. That's the y value. Let's go for D. Question 8. Initially a spark field with... Oh, I forgot how to do these. That's not good. So initially a spark pool is filled with 800 liters of water that contains a quantity of dissolved chemical. It is discovered that too much chemical is contained in the spark pool water. I can't read today. To correct the situation, 20 liters of well-mixed spark pool water is pumped out every minute, while 15 liters of fresh water is pumped in every minute. The cubic number of kilograms of chemical that remains dissolved in the spark pool after 10 minutes. Differential equation of relating Q and T is... Okay. I wonder if I can use my mixture program to do this. Because I'm going to be completely honest, I forgot how to do that. So let's see if this can save me. So it's calculus, and I'm going to go to mixture, run it. Initial volume, 8,000 liters. Initial mixture per unit volume. I'm just going to go with 0. There's nothing, because we don't really know. Total inflow per unit time. So 20 liters. 15 minutes is pumped in. So initial inflow mixture per unit volume. Fresh water, so 0. Total outflow, it's 20. Find solution, don't care. So 4x divided by t minus 1600. Let's go with option A. Question 9. The position of a particle moving in the Cartesian plane at time t is given by the parametric equations. What is the slope of the tangent to the path of the particle when t equals 2? So I'm going to define it. So define x of t equals 6t divided by t plus 1. And I'm going to define y of t to be equal to minus 8, and then divided by t squared and then plus 4. Right? And what we need to do, we want to find dy dx at t equals 2, which is dy dt over dx dt at t equals 2. So let's do that. So we want to do fraction. We want to do shift minus, and we do y of t over the derivative with respect to t of x of t. Okay, and we do this at t equals 2. We get 3/4, and that's option D. All right, question 10. Integral. Nice. N is, okay. So we have, this is probably, yeah, it's integration by parts. Let's see if we can do this. So what do we want to differentiate? What do we want to integrate? We want to use the DI method. I don't know if this is a standard thing taught, but it's the way I do it. So 1 minus x to the n, and then integrate e to the x, which remains at e to the x. Differentiating this guy gives you negative n, and then 1 minus x to the n minus 1. Right, because, yeah, n comes down, and then you got the chain rule on the inside. So this part over here is a solution, and then every row is a new integral. So we have 1 minus x to the n, e to the x, evaluated from 0 to 1. And then we also have plus. We have n integral from 0 to 1, 1 minus x to the n minus 1, e to the x dx. So this guy over here is equal to, if we plug 1 into it, it's going to go to 0 because of this factor here. So we're going to do negative and then plug in 0. So what happens if you plug in 0? You're going to get 1 and then e to the 0, which is 1. So just negative 1 and then plus n. And then this guy over here looks like it's just going to be I of n minus 1. It's a nice recursive formula there. Yeah. Question 11, the area of the surface of the curved surface generated by a revolving part of the curve y equals cos inverse from this point to this point about the y-axis can be found by evaluating. Let's see. So cos inverse looks like, what does it look like? It looks like this, I think, if I remember right. So this is 1, 0. 1 comma 0, and then this point over here, that's negative 1 comma pi. From 0 to pi on 2, so that's this point over here, to 1 comma 0. So we're just rotating this section of the curve about the y-axis, so we're going to generate some kinds of, funny upside down cup kind of thing. Can be found by evaluating. So let me remember how the formula works. So it's going to be, you integrate, because we're rotating about the y-axis, it's the integral from 0 to pi on 2. So we're integrating along this direction. And we want to integrate cosine of y in this case times something dy. What's that something? It's going to be the square root of, I think it's 1 plus dy on df on dy, but squared. So f in this case would be cosine. So you just got to imagine yourself flipping, doing the inverse function whatsoever. So f is going to be cosine. So df on dy is going to be negative sine. So negative sine squared is sine. So this is 1 plus sine squared of y. Does this match anything? I think so. So it's not going to be C. It's not going to be these guys. So it's going to be D or E. So maybe we can try substitution. We would want to let U be equal to the sine here. So that U equals sine. And then it wouldn't be this. It wouldn't be D because the bounds haven't changed. It would be E. So if you let U equals sine, you reduce this cos y dy changes into du. This is just the square root part. And then, if you plug 0 into the sign here, you get 0. So terminal starts at 0. If you plug pi and 2 into the sign, you get 1. So it has to be option E. How are we going for time? We're only up to question 11, and we're at 19 minutes already. I don't know if I'm slow or if these questions actually take quite a bit of time. So acceleration of a particle that starts from rest that moves in a straight line is described by this thing, where v is velocity. The velocity of the particle after this amount of time is. So we have dv on dt equals 1 plus v. And I want to find the solution for v. So do we have to integrate this? Probably. So dv over 1 plus v equals dt. So log of 1 plus v equals t plus c, it starts from rest. So at t equals 0, v equals 0 as well. So plugging everything in, we get log of 1 equals 0 plus c. So that tells you, log of 1 is 0. So that tells you c equals 0. So that means, if you rewrite this differential equation, or this equation rather, you get 1 plus v is equal to e to the t, so v equals e to the t minus 1. And so v at that particular time, so v of log of e plus 1 is equal to, we have, e to the t, which is log of e plus 1, and then minus 1. So that's going to be e, because the e and the log will cancel, leaving you with e plus 1 minus 1, which is just e. Alright, question 12. That was question 12. Question 13. Tourist in a hot air balloon rising vertically at this particular rate accidentally drops a phone over the side when the phone is 80 meters above the ground, assuming blah blah blah. So this is your SUVAT over here. So let's use the SUVAT program. So we can go to the motion library, go to SUVAT, and what's SUVAT? SUVAT. So A is negative 9.8. S is, do we know what S is? It's 80. And U is initially 2.5 upwards. V is, we don't care about what V is, and we care about the time. So let's plug that in. So we have 80, 2.5, I don't know. Actually, we don't want to use that. Let's use A. And then we have negative 9.8. And then we have something we don't know. Unable to find a real valid solution. That's not good. Let's see. S is 80. U is 2.5. V we don't care about. Acceleration is 9.8. S should be negative 80. Right, because we're trying to find how long it takes to reach the ground, which means it would have been displaced by negative 80 meters. So yeah, we're not going to take this solution. I'm going to take this solution, so 4.3. I don't know which equation you would use though, if you were to do this manually, but yeah, it's probably in your bound reference or something. So we have A equals these guys over here, n is a unit vector such that n equals 0, b n equals 0, then cn is equal to, So we know n's perpendicular to A. N's also perpendicular to B. Then C times n is. Can we write this? Are these vectors linearly dependent? Because if they are, we can just use linearity of the dot product. Let's test that. So we have m-spec vectors. That's the one. I want to see if they're linearly dependent. So lindep test. And I'm going to put in the vectors. So 1, 1, 0. And then we have 1, negative 1, 0. And then we have 1, 2, 3. Vectors are linearly independent. Okay. Then Cn is, So you can't write C in terms of A and B. Is C the cross product? So let's do cross P of this guy and also this guy. It's not the cross product. So how do you compute that? So maybe let's draw a picture. So here's the here's our plane over here. So what's A? A is I plus J. So I plus J is going to be sitting over here. I minus J is going to be sitting over here. So it looks like A and B are both in the XY plane. And because n is a unit vector which is perpendicular, it's non-zero, so it has to be sticking up on the y-axis. Okay, so we can just say, because we're taking the modulus at the very end, it doesn't matter which orientation we choose. So we can just pick C to be equal to, n to be equal to. We'll take 0, 0, 1, that's a unit vector. And yeah, if you dot it with C over here, you're just going to get 3, which just extracts this third component. So we'll go with B. Question 15. If the sum of two unit vectors is a unit vector, then the magnitude of the difference of the two vectors is... So you have a unit vector, and if you have another unit vector, if the sum of two units vectors is a unit vector, then the magnitude of the difference of the two vectors is... So if the sum is also a unit vector, so it can't be like 90 degrees because the sum would be over here. I'm thinking of maybe it has to be like a triangle kind of thing. Because if this is a unit vector, if this is also another unit vector, if it's an equilateral triangle, then this third side is also the same. So that means the magnitude of the difference of the two vectors is... So you have one vector pointing this way, the other vector is pointing this way. This angle would be 120 degrees. So maybe we can use... What's the cosine rule? It's c squared equals a squared plus b squared. Is it minus 2ab cos c? Probably. So we have c squared is... Yeah, c squared is c squared. This is 2. And then we have minus 2 times a times b, which is just 2. Cosine of 120. What's cosine of 120? It's negative half. Alright? So this is just equal to 2 plus 1. Which is 3? No. Okay. What's cosine of 120? I don't know. Cosine of 120 is 2 pi on 3 radians. It's negative half. The magnitude of the difference of the two vectors is... Oh, because I need to take the square root to get c. That makes sense. So this is a half, so this is equal to 3. So yeah, c is equal to root 3. Option D. Question 16. A student throws a ball for his dog to retrieve. The position vector of the ball, okay, it's some vector function, it looks like displacement, blah, blah, blah. The total vertical distance in meters traveled by the ball before it hits the ground is closest to. The total vertical distance. Okay. So I is a unit vector to the east, j is a unit vector to the north, and k is a unit vector vertically up. So we can take a look at that third component there, because this is just the vertical distance. So we just need to focus on this component here. And take a look at, how much it goes up and how much it goes down, pretty much. So I'm going to define, let's call it f of t to be equal to 15t, and then minus 4.9 t squared, and then plus 1.5. Let's hopefully I got that right. Okay, so let's graph this because I don't know what it looks like. So dot 44, we have, I'm going to del var x, because that's going to be interfering with the graphs page, the f of x. So it looks like it's that. So it starts, let's analyze this. So we have methods, functions, we have analyze, and then f of t with respect to t. I want to analyze with the domain. So do this, and then we go from 0 to infinity. So start points looks like it starts vertically at 1.5, and it goes up to a maximum of 12.97. So what I will do is I'll take the 12.97. So that's how much distance it'll take before it hits the ground from the maximum. And then I also need to add, so I'm gonna add it again, so basically times 2. And then I'm gonna subtract off the initial starting height, which is 1.5. So 24.45. Looks like it's D. Question 17. 4 more questions. Surely some line plane questions. Consider the vectors. Okay. If cross product is C, then we can probably solve this on the CAS. So consider the vectors. So we have alpha, and then we have beta over here. So those are our unknowns, it seems like. So just the alpha and the beta, and the gamma as well. So we have alpha, we have the beta, and then we have the gamma. Okay. So what I'm going to do is I'm going to define A equals, we're going to have alpha. I don't know how to represent alpha. Let's just do AL for alpha. And then we'll do 1, comma, and then we'll do -1. And I'm going to define B equals, we have 3, comma, beta, comma 4, and then we have C, so I'm going to define C equals, and we have 2, -7, and gamma. Right, so what I'm going to do is I'm going to compute the cross product of A and B. So A and B. So we get this over here, and I'm just simply going to solve. Actually, is it possible to solve vectors? Solve C equals this guy for alpha, beta, gamma. Oh, it is. So alpha is 1, beta is -2, gamma is -5. So it's going to be option C. All right, planes. Awesome. For what value of k makes the following planes perpendicular? So we want the normals to be, we want the dot product of the normals to be 0. So we want normals to be perpendicular, which means the planes are going to be perpendicular. So what's the normal of the first plane? It's 2, comma, -k, comma 3. And what's the normal of the second plane? It's 2k, and then we have 3, and then -2. So what's the dot product going to be? It's going to be 4k minus 3k, and then -6, and we want this to be equal to 0. So what's 4k minus 3k? That's k, and then -6 equals 0, so k has to be equal to 6. You could probably verify this on the CAS as well if you have the programs. So we'll go to special line planes, we'll go to 2 planes, where is it? 2 planes, and then we'll just type in the planes, so 2x and then minus, was it 6? Yeah, or 6y, and then we have plus 3z. I'm going to redefine that actually, the y and the z, because that's going to interfere with the programs. And then we have 12x, because it's 2k, and then plus 3y, and then we have a minus 2z equals 4. I'm going to deliver y and z because that's interfering with the program, and yeah, acute angle is 90 degrees, so it's perpendicular. Okay, question 19. A company accountant knows that the amount owed to an individual unpaid invoice is normally distributed. So n, and then mean of 800, standard deviation 200. Probability that in a random sample of 16 unpaid invoices, the total amount owed is more than 13500. So x bar is normally distributed 800, and then we have 200 squared divided by 16. So this is just 200 divided by 4, or 50 but squared. And we want the probability, so the probability that the total, so the sum of all the random variable is greater than 13500, is the same as the probability that the mean is greater than this number divided by 16. Right, because if you divide both sides by 16, the left-hand side reduces to the mean. So what's 13500 divided by 16? Let's find out. It's going to be 843.75. So 843.75. So let's just do the normal distribution. So probability, we have normal distribution, normal CDF. Lower bound is 843.75. Upper bound is infinity. Mean is 800. And standard deviation is 50. So 0.1907. So it looks like it's option B. Final question, question 20. Lifespan certain electronic components is normally distributed with a mean of mu, standard deviation of sigma. Given that a 99% confidence interval based on this stuff is here, value of sigma is closest to. Now I really feel bad about not making the solve confidence program for SPECH. That would have been nice for this question. Anyways, So we just got to remember what's the margin of error. Actually, what's the sample mean in this case? So x bar is going to be equal to 10 500 plus this guy over here, and then divided by 2. So it's going to be 1300. Okay, so that means the margin of error is going to be one of the endpoints, subtract that off, so that's going to be 2500. Right, but the margin of error, we know that's equal to the z-score, so we need to get the z-score for the 99% confidence interval. So how do we get the z-score? We got to do, if you think about it, 99% confidence interval means everything in here is 0.99. So you want to do inverse normal of that little region there, which is 0.005. So if we do that, if we just do menu, probability, and then distributions, we do inverse normal of 0.005, we get 2.57. So this is, if you just take the negative of this guy over here, that's the z-score we're working with. So we'll save that for later. Okay, so it's equal to the z-score times the standard deviation. Right, but the standard deviation is sigma, which is the population standard deviation, divided by the square root of n. What's n in this case? It's 100, so square root of that is just 10. So we're just going to solve this. So we're just going to solve 2500 is equal to this number, and then, yeah, times sigma divided by 10, solve for sigma. 97, yeah, it's going to be A. Perfect. All right, so that's multiple choice there. I took like 36 minutes to do that, which I guess isn't too bad, given that I'm quite rusty on this stuff. But yeah, I think that was a very fair multiple choice section. It really wasn't anything too special, I think. Yeah, not too bad at all. So yeah, I don't know if I'll do extended response now or tomorrow. I'll see though. But yeah, that's my multiple choice solutions. Let me know if I got anything wrong. And yeah, I'll see everyone in the next one.